Hi, I'm Rich with ISC'14. We're here at ISC'14 in Leipzig, Germany at the Panasas booth, and I'm here with Geoffrey Noer once again. How are you doing, Geoffrey?
Hi, Rich. Very good.
Good. Well, thanks for having us. You know, I thought we'd start at the beginning. Who is Panasas and who do you help?
So Panasas, of course, has been focused on hybrid scale-out NAS for HPC and technical computing in the enterprise for many years. So we're here again at ISC to show off our latest and greatest. We have a new platform, ActiveStor 16, which you see in front of us, and we'll talk about in a few seconds.
Okay. So new hardware with more capacity. So is this hit here? And I see it's got some interesting new disk drive technology with Helium.
So of course we have our plexi lid version to show off at the trade show.
Right.
And yeah, we're now shipping with 6 terabyte drives, or we will be a little bit later this year in September. This is using helium-filled hard drives in order to improve the areal density and lower power consumption. And so we're now up to 122 terabytes in a single 4U shelf. So 50% increase in density. We also have 4 times as much memory in our director blades that handle metadata and the NFS and CIFS protocols. So that will also help with performance, along with some additional CPU speed.
Okay, so that's interesting about the energy. So these Helium drives, when you add this up into petabytes, that's got to stack up into a lot of saved energy.
Yeah, I mean, servers consume the vast majority of the power in the data center, so that's the first thing that people look at to try to save power.
Yeah.
But you know, every little bit that you can do anywhere in the data center infrastructure helps.
Okay. Well, what about reliability? As these big arrays of storage get bigger, there's just got to be a lot more errors coming in.
Right, and so Dr. Garth Gibson, who helped found Panasas, was one of the 3 original inventors of RAID back at University of California at Berkeley in the 1980s. So the concepts of RAID and especially the hardware RAID, where you're doing data protection at a whole hard drive level, that's been with us for a very long time now, almost 30 years. And it's really time for a shift as the drives have now gotten much larger. The chances of running into unrecoverable read errors is very high now that you have 6 terabytes on a single drive. And so the opportunity to do something very different with data protection allows you to really differentiate your product. And here at Panasas, we've always had a product based on erasure codes in software rather than on hardware RAID controllers. But with this product announcement, we've launched PanFS 6.0, which is our new version of our storage operating system, and that has RAID 6 Plus. And this delivers actually triple parity protection, which increases the base reliability of the product by about a factor of 150 times.
Wow.
So not like a factor of 2, but it really is 150 times more reliable. Mm-hmm. However, we've actually gone beyond that because the reliability of the system actually improves with scale rather than getting worse. And that's a big difference from most other storage systems, where if you have a 1% chance of a failure on one hardware RAID array, as soon as you have 10 of them in one system, you have 10 times as high a chance for failure. Yes. But in our system, RAID rebuild speed scales linearly with the size of the system. So that system that's 10 times bigger rebuilds in 10 times the speed. So that means your exposure window for failures is 10% as it was in the smaller system. So 10% is 10% of a failure window with 10 times as many failures equals an even risk as you scale. So that's kind of the first thing to understand. The second thing is that we scatter files across increasingly large numbers of drives as you get big. And this means that if you were to be so unfortunate as to have 3 simultaneous failures, low probability, but it could happen, you're less and less likely to hit individual files as you get big. And so the percentage of files that we would expect to be damaged by a catastrophic failure gets smaller and smaller as the system gets bigger, which is a big advantage. When you think about the challenges of deploying storage at the scale of petabytes or tens of petabytes or hundreds of petabytes, unstructured data growth everybody knows about that. And that's becoming a challenge. And if you don't do something about the reliability and the availability model, the traditional RAID techniques are really getting to a breaking point.
Right. I mean, it's gotten to the point with these bigger drives that by the time you would rebuild a RAID, something would fail again, and you'd be really in trouble, wouldn't you?
So let's talk again a little bit about the consequences of having too many drive failures. It's not something that storage companies like to confess to, right?
Yes.
But every storage vendor of any consequence has had data loss in the field.
Yeah.
It's because you're deploying, in many cases, hundreds of thousands of hard drives. It's just a matter of probabilities and statistics. And actually, the more you sell, the more likely you are to have customers that will run into this. And most people know people who have lost data.
Yes.
So, of course, we do everything that we possibly can to prevent that situation from happening in the first place.
Right.
And the triple parity data protection will hopefully prevent that from ever happening. But if it does happen, we want to minimize the effects. So with a system with only 100 drives in it, if you were to have 3 simultaneous drive failures, one too many for the data protection, we would only expect that you would lose 1 in 200,000 files, as opposed to losing the whole file system. If you scale it to 1,000 drives, then you're looking at 1 in 200 million files. So reliability increases by a factor of 1,000 when you scale the system by 10x.
Wow, that's incredible.
And we're actually protecting the directory structure 1 degree deeper, which means that we can name the files that were damaged. So you're probably looking at restoring maybe 10 files in a large-scale system if you have a catastrophic failure. And we keep the system online so users can continue to access it. So that's the other important thing, is we've moved away from an all-on or all-off method to we try our best to always stay on, but you may not access every file depending on the health of the system.
That's really exciting. I mean, especially with this enterprise technical computing, right? You got a business to run. And,
Absolutely.
Failure is not an option.